Hey, how's it going today, guys? For today, we'll be going over the life of Guglielmo Marconi for our Physics 152 exam.
Marconi was born on April 25th, 1874, at Bologna, Italy. He's the second son of Giuseppe Marconi, an Italian gentleman, and Annie Jameson, daughter of Andrew Jameson of Daphne Castle in the country Wexford, Ireland. He studied the works of physical and electrical science through James Clerk Maxwell, Heinrich Hertz, Augusto Righi, and others such as Sir Oliver Lodge. In 1895, he began experimenting in his father's laboratory estate in Ponticchio and succeeded in sending wireless signals at a distance of 1.5 miles. In 1896, he moved to England with his utilities to meet with Sir William Preece to promote his newfound invention. His educational background was that he was actually educated privately in Bologna, Florence, and Leghorn. And as was stated before, he worked under Heinrich Hertz, James Clerk Maxwell, and Sir Oliver Lodge. And his main mentor was Augusto Righi.
So, for one of his notable scientific discoveries, Marconi succeeded in sending wireless signals in a distance of 1.5 miles in 1895. He was also granted the world's first patent for a system of wireless telegraphy in 1896. In that same year, he also demonstrated his invention in London and later founded his company in July 1897 called the Wireless Telegraph and Signal Company, which was later called Marconi's Wireless Telegraph and Signal Company, limited in 1900. Later on in 1900, in that year, he also demonstrated to the government of Spezia that wireless signals could be transmitted across 12 miles. And the year before that, in 1899, he established wireless communication between France and England across the English Channel, which promoted permanent wireless stations at the Needles, Isle of Wight, and Bournemouth, and later at Haven Hotel, Poole, Dorset. For others notable scientific discoveries he had made, in 1900, he took his patent number 7777, or as also known as tuned and syntonic telegraphy, and determined in December 1901 that wireless waves were not only affected by the curvature of the Earth due to the distance of how far it can transmit, which is 2100 miles through multiple frequencies. And as you can see on the right, it shows his patent or his tuned and syntonic telegraphy. Another scientific discovery he made was, well, it's not really a scientific discovery, but he was also a recipient of honorary doctorates of several universities and many other international honors and awards, such as the Nobel Prize for Physics. And in 1909, he shared with Professor Carl Braun the Albert Medal of the Royal Society of Arts, the John Fritz Medal, and the Kelvin Medal. And as you can see on the right, the image is the John Fritz Medal. So for how the telegraph works, the telegraph, the wire telegraph has three elements: a transmitter, a receiver, and a conducting medium. In wire telegraphy, the originating message is encoded in Morse code using a system of interpreted electric current. The receiver detects a series of interruptions, and through the electromagnetic pulses, it converts them to audible clicks that relays the coded message. The operator then translates the click patterns to Morse code equivalent and then to its original message. Overall, landline telegraphy relies on wires to carry the pulse electric signals, which is a method limited by the amount of wire there is.
In comparison to the wired telegraph, Marconi's wireless telegraph uses air as a contact medium rather than a wire. It also has two antennas, transmitting and receiving. In the transmitting antenna, it radiates the electromagnetic field created by a current from the spark coils in every direction at the speed of light. The receiving antenna then receives the signal and reverses the process. The electromagnetic radiation is converted into electric current, which is then translated at the receiving station.
So as you can see here, this is a diagram of what the wireless telegraph be. So the B would be the battery, which it conducts through the the conduction, which would send out electromagnetic pulses, which could then translate to the D and T area, where it would go to the receiver, receiving the encoded Morse code. So the quote that we chose was, "Success is not measured by how many obstacles you avoid, but by how many you overcome." So the quote that we chose from our previous five was from the many quotes that Marconi has written in his books. He published at least three books, but the first book he published noticeably was The Improvements in the Apparatus Employed in Wireless Communication, which talks about his notable discovery in wireless communications. The second book he published was History Speaks Volume 3, which talks about how he was one of the many physicists who discovered something extraordinary in their time. So the reason why we chose the quote from our last slide was because it highlights the importance of perseverance and resilience in achieving an individual's own goals. Therefore, with the right amount of ambition and steps to move forward, there needs to be ways on how to overcome obstacles and provide courage to overcome those obstacles to reach a specific individual's goals. Thank you for listening, and this is our works cited page.